All right, in this video, we're going to take a look at some further examples for finding the domain and range of inverse functions. So part C, we have h of x is the square root of x plus 2 and then minus 1. We found in the previous video the inverse of this is x plus 1 in parentheses squared minus 2. However, we do have a little bit of an issue here. So if we take a look at our original function, here's our original function. If we take a look at the inverse as well, the x plus 1 in parentheses squared and then minus 2, at least I think that was it. Yeah, okay. First up, this fails the horizontal line test. And if we take a look at the graph of our original function, it definitely is not a reflection of the blue original function graph over that diagonal line. So what we need to do in order to remedy this situation is we do need to look at maybe making a domain restriction on this inverse function so that way it is a reflection of our original function across this graph. Now, to do that, if we look at our original function here, we have an x plus 2 inside of a square root, so x plus 2 in our original function has to be greater than or equal to 0, which means x has to be greater than or equal to negative 2. And we can even see that in the graph. All of our x values start at negative 2, and they just keep going up from there. So like 1.13, 4.62, etc. That is going to match the range of our inverse function. So unfortunately, that doesn't really say too much because the lowest y value here is negative 2, and they all go up in y value from there. Okay, but at least, hey, we have one less thing we have to worry about. Now, for the domain of our inverse function, let's actually instead look at the range of our original function. So I'm going to put that original function back up. Here's our original function. Our range values are starting at y is negative 1, and they're just going up in y value from there. So looking at the graph of our original function, the range of our original function is y is greater than or equal to negative 1, which means that's going to be the domain of our inverse function, x is greater than or equal to negative 1. And if we take a look at, here's our function here, if we make the domain restriction that x has to be greater than or equal to negative 1, now if we take a look at these graphs, now we can see that they are in fact reflections across this diagonal line. So sometimes we do have to make domain restrictions in order for that to happen. And in this case, as far as I'm concerned, and your mileage may vary here, but I like to find the range of the original function, especially when dealing with square roots, and copy and paste that down into the domain of the inverse. So our domain of our inverse function is greater than or equal to negative 1, bracket negative 1 to infinity, which we could have just as easily copied into this cell. And then the range of our inverse function, greater than or equal to negative 2, is bracket negative 2 to infinity. So again, try to graph when you can, because a lot of times it'll help you out. All right, part D, we have j of x equals x squared minus 2x plus 4 with the stipulation here that x has to be less than or equal to 1. So here's the graph with the stipulation. Here's the graph without the stipulation. So if we did not include this part here where x is greater or less than or equal to 1, then this is what the graph would look like. And notice this one fails the horizontal line test. So in this case, we made the domain restriction to be less than or equal to 1, so it looks like this. However, we could have just as easily said greater than or equal to 1, and it would have been the right side of this graph. In fact, we could have even not had it go to 1. We could have had it stop at 0. So we can really restrict it how we want as long as it passes the horizontal line test. All right, so looking at our function here, we need to find the inverse of this. So we have not done that previously. So we'll switch the x and the y. So we have y equals x squared minus 2x plus 4. Switching our x and y, we get y squared minus 2y plus 4, which we want to rewrite this in standard or vertex form. So if I look at what the graph is going to look like, let me eliminate these ones here. Here's what the graph would look like. And again, not using the x's and y's here, or the restrictions here. Here's what the graph looks like. So our vertex is at 1, 3. So going back to writing it in vertex form, we get x equals y minus 1 in parentheses squared, and then plus 3. So again, the value of a here is 1, so we can put a 1 in front of the parentheses, and then in vertex form it's minus 1. Here I have the plus 3. Some people like to put the minus 3 over on the other side, but subtracting 3 from both sides, we get x minus 3 equals y minus 1 in parentheses squared. Square root both sides. Remember, when we square root both sides, we got to consider the positive and the negative. So we have y minus 1 equals plus or minus the square root of x minus 3. And then we want to add 1 to both sides, and we get y equals 1 plus or minus the square root of x minus 3, which means j inverse, the inverse function for j is 1 plus or minus the square root of x minus 3. So let's take a look at that. Once again, here's our original function we were given. Get rid of this. So our inverse function is 1 plus or minus the square root of x minus 3. I'll take a look at that. So 1 plus the square root of x minus 3. Make sure that's correct. Yeah. And then we also have 1 minus the square root of x minus 3. So here we have the plus in red going up, the minus in blue going down. However, looking at this reflection here, it can't be both, because this this would fail the vertical line test. So it's either got to be the upper part in red or the lower part in blue. And in terms of visualization, if we test out the graph in red, notice that this graph in red is not a reflection across this line for the original function we had. So, however, the graph in blue is a reflection across that line. So looking at what we actually have as our inverse, plus versus minus, with the 1 plus or minus there, it's actually 1 minus the square root of x minus 3. From a visual standpoint, our original domain are values of x that are 1 or lower, which means our range values have to be y is 1 or lower. And if we look at this graph, our range values are 1 for y and going up. So again, it not only does it have to be that reflection, it has to have that domain and range switch. So let's take a look at our information. Here, our original function, it told us the domain, so it passes the horizontal line test. So we can just copy that domain down into our original function. That's going to match the range of our inverse. So if we look at the output values here, all of our y values start at 1 and then go down from there, like negative 0.503. Our domain of our inverse, we have an x minus 3 inside of a square root, so x minus 3 has to be greater than or equal to 0, which means x has to be greater than or equal to 3. So again, looking at our inverse here in blue, we're starting with x equals 3, and then all of our x values are greater than 3, like 5.6 or 5.58. That's going to match the range of our inverse function. So y has to be greater than or equal to 3 for our inverse function. So our domain of our inverse is greater than or equal to 3, so it's bracket 3 to infinity. And our range of our inverse, less than or equal to 1, is negative infinity to 1 with a bracket after the 1. All right, so that about does in this video. Thanks for watching.